Hello again, everyone. Welcome back. This is Bob Martin with the Nautilus Drydocks, and we're going to continue our journey to get this 177 scale Disney Nautilus fully operational for RC control. Hope you join me for part 1 of the build. If not, you're going to be a little bit confused as we are now on part 2. We're going to be working on some cosmetic things on this boat, prepping the hull, getting it all ready to look beautiful, and then in the following section, the last section, we'll get to the technical aspect of installation of the running gear. So, without any further delay, let's move on to getting this thing prepped. Alright, this section here is not going to take long. I am not going to dwell upon it because it is very straightforward. We're going to install some of these detail pieces into the lower hull area. Simply match them up and glue them down. I'm going to be using some rubber reinforced cyanoacrylate for strength, durability, flexibility. We're just going to move real quick in here. So let's start with the lower hatch. Now you can certainly, if you would like to, make this fully operational. It's not really going to help anything because you need to run with it open to make it work as a drain hole. So all I'm going to do is I'm actually just going to glue that right in place as it sits. And just as a preamble, in the first section, again, all of these parts were cleaned with a mild solution of soapy water. And they were also cleaned to flash using a hobby knife and file. So lower hatch is now in place, permanently mounted. Let's move on to our anchors up in the front of the hull. You're going to need to trim these because they're going to sit a little bit proud, a little bit long, as you can see there. So I'm just going to trim them about 1/4 of an inch off, so that when they go on there, you've actually got 3 points of contact with the hull, the main shaft and then the 2 tines there as well. So the main shaft is going to be glued in place with the rubber CA. Like that. Making sure that everything is vertical so it doesn't look strange hanging upright. There we go. And we are going to do the same thing on the other side, but I'll do that off camera. Now we got our spiral speed indicator here. This is this corkscrew deal. And that gets put right in this front opening of the hull, like this. And for placement, the rear shaft, this little beveled, angled piece, sits flush with the rear face of the keel. 2 little dabs of CA. Now, you can use thin CA, and it'll look better. You won't get any oozing of glue as you might with this thick CA. But for an RC model, you really want to go with durability. The last thing that you want to do is come back from your patrol missing a piece, particularly in the keel where it's going to be bouncing around on the bottom of the water. So in the center hull, you've got 2 pieces that you're going to be installing. One is this kind of ice cream cone collective that you see, and the other one is this large assembly area here. The front one simply goes on like this, and you'll note that there are tabs and slots where everything gets locked into place. So that's going to get installed right there. Alright, we got our forward detail piece, our rear detail piece in place, we have our hatch in place, we have our anchors in place, and the last thing to do is to add our little hatch wheel. These are really delicate pieces. I'm just going to put just a tiny dab of glue over that hole and set that in place. There we go. All right, the detail pieces have been installed on the lower hull. You can see that mounting screw for the upper fin assembly that we did earlier on. Moving forward, there's this rear ice cream cone assembly, hatch wheel, and that's still got some accelerator drying on there. There's our forward assembly, our spiral speed indicator, and our anchor. So that concludes the detail pieces for the lower hull. Now we're going to move on to the upper hull. Alright, let's continue on with a couple of more detailed parts. I got the upper hatch. This is the larger of the three hatches, and our dorsal fin. So we're going to set our hatch in place and our fin. Now you want the orientation of these two pieces to be set so that the hinge bracket on the fin is exactly in between the two arms on the hatch there. Once that's in place properly, the hatch can hold the fin in the perfectly vertical position, but double check that. You want to make sure, just by eyeballing or utilizing a square, that that fin is perfectly vertical. And once that's done, I like to use a little bit of thin cyanoacrylate. This has a water-like consistency, and you just put that at the base of the fin, and it'll flow all through the bottom joint there. So with that in place, I'm just going to hit a little bit of accelerator on there, and that'll be locked in place. Now, you've got a couple of options here. For an RC model or a display model, making this hatch functional is beneficial, because in an RC version it'll allow trapped air to vent through this section, and what we're going to do is install the hinge pin for that right now. So what you'll need for this is one of two things. I have a little electric drill with a very fine chuck in it, or you can use a finger drill or a thumb drill, and this will do the same thing. I'm also going to use some really fine gauge brass rod to form the pin. Now the location of your pin is marked out on the outside of the hatches. So what you're going to want to do is pinch or trap the hatch with your finger, and then drill through the entire assembly utilizing your drill, either your thumb drill or your electric drill. By running the bit through there, clean out the cuttings. Now we can run the rod through the entire assembly. Let's give it a little wiggle. And there we go. I'm going to back that out so that it's flush on the outside. With that done, I can trim off the excess, and we have got a fully functional rear hatch. So the only thing left to do here now is install the hatch. That's our operational dorsal hatch. That'll allow a really nice, display feature for when you've got this, sitting on your shelf or as a display, and then it's also functional for RC operation. Let's move on to the skiff. Two pieces for that. We've got the covers and we have the skiff itself. Now you can get very creative with this if you would like to. If it's a display version, what I've done in the past is embed some magnets in the forward and back, and you can actually clip this on magnetically. As this is going to be an RC model and not a static display model, I'm simply going to adhere or glue this in place just like this. And for that, I'm going to break out my trusty rubber reinforced cyanoacrylate front and back here. Check the centering of the part, and once I'm happy with that, hit it with a little bit of accelerator. Now, the other thing to note is that because the seams are open right now, there'll be water that gets in there. So what I want to make sure that I do is put a bead of glue around the perimeter of that joint so that it forms a perfectly watertight seal. There we go. So once that's dry, that'll be nice and watertight. It'll actually help add just a tiny little bit of flotation to that rear assembly with that trapped air. So to actually mount the skiff, I do want to make it removable, but I don't want it to fall off, obviously, during operation. So I am going to utilize magnets to do so. These are 1/8 by 3/8 magnets. I ordered them online, but you can get them at your local hardware store. In order to do that, what I am going to do is in the center of the skiff, I'm simply going to drill in right in the keel and install one of the two magnets. Making sure that it sits flush with the bottom. There we go. Now what we're going to need to do is make sure that the magnet lines up with the boat. So what I'm going to do is take a measurement front to center, front to center, mark it out, and drill another hole. So you're going to want to check and make sure that you get your polarity correct so that the magnets stick to each other. That confirmed, you're going to drop that magnet in the hole and apply a little bit of glue. Okay, we're going to move on to the rear part of the hull, and we're going to look at these prop shrouds. They go on just like this. And as you can see, they attach to both the upper and the lower hull, which is a problem if you want to take this piece off. So the first thing that we're going to do is ensure that we have a proper fit. Typically when you get these kits, this side keel needs to be filed out so that the prop shroud sits flush. So what I'm going to do is just going to use my file check out the fit and just keep working until we get a perfect fit. Really close there. Very good. So that's bang on there now. So what we're going to do is mark out the exact center of that side keel. And now we are going to break out our razor saw again, and we're going to split that piece right down the middle there. So now we have an upper and a lower piece, and we're going to glue those on with our rubber reinforced cyanoacrylate. Okay, I've got the rear prop shrouds adhered to the hull. The top piece is adhered at the top and at the side keel. The bottom pieces are only adhered at the bottom. Now what we are going to do is install our prop shroud supports. And this is actually a fairly easy thing to do. What you're going to want to do is measure out and mark exactly halfway between the side keel and the vertical keel. Mark that on the prop shroud, and then these pieces go in just like this. Now, I will say you're going to need to file and trim the leading edge so that it sits nice and flush in these recessed pockets. So let's go ahead and get that done. One quick thing of note as you're putting these on, however, is you're going to want to leave off one of the prop shroud supports on either the port or starboard lower side, because we're going to be running some linkages in a new part that we're going to be making. So at this point, only put on 3 of these, 2 tops and 1 bottom. Okay, this next stage is actually going to involve a specialty tool, and that is this 1/8 inch extended length drill bit, and I got that mounted in my standard cordless drill. Now the objective here is going to be to drill a hole through the hull originating at the forward edge of this pocket for the prop shroud. And the idea behind this is to run linkages from the inside of the boat out through this prop shroud support out at this point and connect to our rudder linkages so that we hide all of that for a nice clean installation. So what we are going to want to do is set our bit in that forward pocket and just start a bit of a pilot. Once you've got it started, you're going to want to orient the drill bit so that it lines up with where the exit for the prop shroud support is going to be. Just keep it right nice and close there and just keep pushing until it penetrates the hull. And the reason you need this extended bit is because ultimately you're going to need about 6 or 8 inches of length in order to get all the way through. And there we go. So as you can see, we've got an exit point on the inside of the hull, right about here. And that is going to be where our linkages are going to enter the boat. Okay, as I said, we're going to use some standard brass square tubing. This is 1/8 inch thickness. We're going to set our length by measuring it out, laying it in place as it's going to be. And you're going to want to mark it out on the trailing edge of the prop shroud. So using a cutting disc, we are going to cut this off and contour the back a little bit, and we'll get that installed. All right, I have cut my prop shroud support, our new one, our hollow one. I've also notched the back of it here, so you can see I've got a little flange that'll wrap over the top just like the other pieces. So what we're going to want to do now is lay that in place, mark out the appropriate location on the prop ring itself. And now what we need to do is actually notch the prop ring to allow the linkage to come through. And I'm going to use this square file. You could use a cutting disc on your Dremel if you wanted to. And then you're just going to want to notch that ring. And you're going to want to go down maybe a 1/16 of an inch or slightly more than that in order to allow the linkage to get out through there. So now that that's done, what we're going to end up doing is putting this in place, run our linkage through there, and then once that's all freely moving, glue everything down. Alright, I have my brass rod in place. I'm using 32nd inch diameter brass rod, and you can see it slides exceptionally freely through there. Very important for binding. Now what we're going to want to do is just rough up the brass a little bit and adhere that to the hull, ensuring that we are not getting any glue into that passage and gluing our linkage in there at all. Okay, let's take one last look at the rear assembly there. I just removed the stainless bolt, and this just lifts right off. So you can see the mounting ring. We've got our upper assembly here with all of the supports in place, and then we've got the lower section here as well. These are supported on both sides, so this is actually pretty strong, and when you drop that down, you got a nice tight seam on both sides, barely visible, allowing full access to the rear assembly area that we are going to work on here shortly. Okay, we are going to continue on with the rudder assembly, and we are going to be installing a rudder, something like this. You're going to note that there is an up and a down to the rudder. The correct orientation is the top of the rudder has the vertical line of rivets down the center of the topmost panel, and the bottom panel is blank. If you get that installed the wrong way, nothing really kind of lines up and it ends up tilted forward. So you're going to want to make sure you've got the correct orientation to make that nice clean line and flush faces top and bottom. So with that in place, what we are going to want to do is mark out on the rudder the center of the pivot block right there, and down on the bottom as well. And that's going to be the location that we're going to put our rudder axis, our rudder shaft, in the piece. And we're going to use 1/16 inch brass rod for that. Drill some holes in and install the shaft. Alright, as I mentioned, we got some 1/16 inch brass rod here, and you're simply going to press that into place in the rudder, and we're going to cut it off with about 3/16 of an inch protruding from the bottom of the rudder assembly. Do the same thing for the top. Alright, here is the completed rudder. What I did is I took these brass pieces out again, roughed up the bottom edge, put them back in, used some thin CA glue, and that adhered these shafts in there permanently. So now what we want to do is mark out exactly the location of those shafts against the upper and lower hulls with our marker. All right, what you're going to need now is some 3/32 brass tubing. And the reason we picked that size is because the 1/16 inch rod slips right inside it like that. This is going to become the bushing for the rudder. So I've actually gone ahead and we've marked out the holes. I've drilled in that 3/32 hole exactly where it needed to be, ensuring completely vertical orientation. Now what we are going to do is drop that in place, mark out the depth, and cut pieces to length, both top and bottom. All right, I got my pieces cut to length. I put a little bit of thick CA in there, but I have not kicked it off. So I have not used the accelerator. I'm going to put my rudder in place there, and on the top, get those holes lined up so that the shaft gets into, there we go. Now that the rudder has basically oriented those bushings where they need to go, now I can use this accelerator and spray it in there and lock it in place. So by doing this, we have ensured that the rudder is nice and free moving and that the orientation of those bushings lines up with the shaft of the rudder. Okay, the next step in our journey is going to be to slice the rudder in order to accept a clear plastic rudder extension that will be used during RC operation, but that can be removed for static display. So I'm going to use my bench vise and a rag. I'm going to grab that nice and firmly in there without damaging the exterior details. Now this part is tricky. I am not going to say that it is anything otherwise. We're going to utilize our razor saw again. Going to go right in the center of the rudder and very carefully, very patiently, back and forth on the one side, line up the other, and do the same on that side. Get them both in, and now maintaining perfect vertical orientation, very carefully, very patiently cut down. And you're going to want to go until the center section is in about a 1/16 of an inch. So we're going to continue that process until this is complete, and then we'll have an invisible slot that we can put that clear rudder extension in later. And there we go, the finished product. You can see that micro thin line in there, again invisible unless you're looking for it, and we'll be able to cut our rudder extension and just friction fit that in place for operation. All right, next step is going to fabricate the rudder horn. I'm going to use some brass flat stock, some really thin stuff. This does not need to be thick at all. This is about a 1/2 inch thick brass stock, and we are going to cut it approximately 1/2 of an inch, so we're going to end up with a 1/2 inch by 1/2 inch square. All right, this is the finished piece that I've ended up with, cut from that brass flat stock. What this looks like is something like this when it's installed. You can see I've got a little flange on the bottom that will allow us to glue the long side to the bottom of the rudder. I've got a 1/16 inch hole to allow the shaft to go through, and a 1/32 of an inch hole to put the actual linkage through. So what we're going to do now, rough up both sides, adhere it with some CA, and we're good to go. All right, the next step is arguably one of the more important, and that is the tilting propeller arrangement in the back of the boat. Now, the Nautilus has several sets of dive planes in it. They got some forward sets, some trim planes, and some rear planes. They look great, especially when you rig them up for practical operation, but unfortunately in real life they do very, very little. They're too close to the center line of the boat, and they are set in areas of high turbulence in the hull. So what's come up with is a tilting propeller arrangement, and the way that that works is you'll have your main drive propeller in the back of your boat, and that'll tilt up and down, and it does not need to tilt very far. You know, about 10-15 degrees gives you some excellent pitch control. So what we need to come up with is a tilting mechanism in the back of the boat, and that all hinges on this piece right here. Now, don't get too caught up on the details about this specific arrangement that I came up with, but this is the kind of thing that you're going to need to fabricate. So what I used was a brass oilite bushing, some 1/16 inch rod, and some flat brass stock, and that's all silver soldered together. Big thing for the orientation of these pins, if you just drill the 1/16 of an inch hole all the way through the entire bushing, and then put the rod through, solder everything in place, what you can do afterwards is just drill out with a 1/8 inch drill bit in the center there, and you've got your bracket, your hinge for your tilting propeller arrangement. And this is going to go right in the back of the boat, right at the very back tip. So you can see we've got a problem here. If you take a closer look, the hull as it comes is got a bunch of resin and blocks of plastic in the way of our shaft, and we can't get our tilting mechanism down in there. So what we're going to need to do now is get aggressive with our hull. We're going to break out our Dremel, and we're going to hog out all of this extra material, and we're going to slice down into the tail to make room for that linkage horn in the bottom. Alright, I got everything set up in my bench vise here, some rag to protect the surface details of the tail as I've got it clamped in place. I'm going to be using two different bits in my Dremel. One is a standard fiberglass cutoff disc, and the other is this milling disc. And again, you can accomplish all of this with hand files and a lot of patience, but tools make things go a lot faster. So what I'm going to do is I'm going to go at an angle this way, and I'm going to go at an angle this way, cut all that stuff out, and then use this bit to smooth it all out and make a nice rounded channel for that drive shaft to go in. So let's get started with that. Okay, we got everything all cleared out there. You can see the big chunk of plastic that we extracted, and a big piece of aluminum on the inside. Now this is put in place obviously to give the tail fin strength, and that piece goes all the way from the inside here through the tail section. You can actually see a little piece in the back here that's been exposed as well. So just bear that in mind. Again, there's some metal on the inside there that you're going to have to deal with, but I've used the cutoff wheel, and now I'm going to utilize the milling bit here to round everything out and make sure that we have full travel for our tilting mechanism. Alright, now what we need to do is cut a slot that it goes down into the tail section, and of course this is again a matter of using the right tool, and in this particular case this is not you know, a specialty tool by any stretch of the imagination. Again, you can use, you know, files, you can use knives, you can use your Dremel, but I find for this particular stage what I like to utilize is this massive cut-off saw for wood. I know it's weird, I know you're shaking your head and thinking I'm crazy, but it works really well to make precisely the right width of cut that I'm looking for and a perfectly straight line down the center line of the hull. So what I'm going to do is just get this exactly in the center and very easily and patiently work my way down until I have the correct depth. Alright, here we can see the finished product. So I've done the primary channel with that saw and I used a file just to open that up. You can see it's going to get a little thin in there, but you know, it's still lots of strength around the front of that keel. We've got room to get our tilting mechanism in place there, and now we're going to move to the upper section of that rear tail, the removable section. We're actually going to install this in there after we remove more plastic from that section. Alright, what I've gone ahead and done is I have cut a couple of lengths of brass tubing that are going to act as the bushings for this tilting arrangement. And what we're going to need to do is mount the entire assembly in the back of the upper fin section here. So what I'm going to do is I'm going to mill out, using this milling bit on my Dremel, right at the center line. Going in across here on both sides. Insert the assembly, glue the bushings without gluing the hinge, and we will have our tilting arrangement. Alright, here is the completed milled out rear section, as you can see here. The slots again are right on the center line of the boat, and the tilting arrangement just drops in place like this. And that tilts back and forth just like that. So I'm going to rough up that brass tubing and secure it in place with some thick CA. Okay, we are now going to fabricate the linkage for that rear tilting mechanism, and what I've used is some really thin brass wire. I've cut off about 1.25 inches of that. I bent it through the hole in the horn, folded it back, and now what I'm going to do is I'm going to solder a length of this 1/16 inch brass rod, making sure that I feed it through this hole first, onto there, and that will give us the linkage that will control the tilting mechanism. Alright, I got the linkage soldered on there. You can see how that tilting mechanism works now. Now we're going to set that on the lower hull, make sure that there's no interference, hog out any plastic that we need to make sure there's no interference, and our linkage should be done. Alright, what I am going to do now is move on to installation of the watertight cylinder. Big thing with this, you want to make sure that you get this ballast tank as close to the center as you can, and conveniently we've got the salon area there to give you reference. So make sure you've got enough room at the back here to run your linkages, but try and keep this as close to the center as you can. So I would say I'm probably about 3/4 of an inch forward of center, which is fine. That'll work out really, really well. And you're going to want to mount this along the center line of the boat as well, and it's going to work out that way because the rear bulkhead is basically going to almost touch the hull at the rearmost point. So the way that I'm going to go about this is I've created some 3D printed bulkheads and forward and back, and the way that this is going to work, I've created a cylinder that goes into that bottom flood hole of the ballast tank, and that's all the way through so water can still get in and out of there. So this is going to go just at that forward leading edge of the salon. That hole's going to line up over the top, And this is exactly where the cylinder is going to sit. And then what I'm going to do is I'm just going to use this U-channel, this aluminum U-channel, and some Velcro. This will get mounted to the bottom of the hull. The Velcro will wrap around, hold it down. That hole that we created in the bottom there will stop it from shifting forward and back, and installation will be as easy as undoing a strap and pulling out the cylinder. So next step, I'm going to go ahead and adhere these bulkheads to the inside of the hull. Alright, let's talk about some of the cosmetic aspects of the wheelhouse now, the wheelhouse area. As you can see here, I've got the upper deck in place, and I painted the floor. I elected to use Tester's copper color for that. I really like using metallic colors in the wheelhouse because it reflects the light from the LEDs and it really makes that area pop, brings out a lot of the detail. So I've got the floor there, also got the wall pieces, and I base coated all of that with a dark silver spray paint, just got from the Home Depot, from Home Improvement store. Works really well. Again, copper and gold to highlight all of the really intricate details of the wheelhouse walls. And then on the inside of the wheelhouse, I did the same thing. Same silver paint, highlighted with some gold around the windows on the inside there. And lastly, I have the ship's wheel that's assembled, painted gold. One thing I do want to note, you can really go crazy with the details inside the wheelhouse area, but unless you've got your eye pressed to the glass, you're really not going to see it. So just bear that in mind when you're painstakingly painting the interior of that area. You really don't have a lot to worry about unless you're really detail oriented. Of course you'll know, but odds are nobody else ever will. So next step, these pieces get pressed into place. There's some orienting tabs inside. So we're going to glue the interior pieces in the wheelhouse there with some thin CA glue on both sides. Okay, we're going to move back to the wheelhouse. There's a couple things that we're going to do with it. We're going to drill out the alligator eyes here to accept some lights, and we are also going to install ladder rungs on the outside of the hull. So let's begin with the drilling out of these alligator eyes, and I'm just going to use my drill press and a 1/4 inch drill bit and a little bit of very careful manipulating to get that passage from the outside to the inside. So each one of these holes is going to be a 2-step process. We're going to want to go in straight into the alligator eye about a 1/4 inch, not far enough obviously that we break through to the outside of that alligator eye. And then we're going to do the same thing from the inside, meet the 2 holes up, and that will allow us to install our LED. Alright, you can see there, gone in about a 1/4 inch, maybe even just slightly under that. And the other thing this has done is it's nicely rounded out underneath that brow. You can see I got some casting residue underneath the other side here. So that's a nice clean hole. Now we're going to go from the inside, and this is the trickier side of the two because you've got the upper receiver for the depth tube, the clear depth tube that goes with it. So we're going to want to avoid that, drill in at an angle that will meet with that first one, and I'm going to use a smaller drill bit for that. So that makes that process a little bit easier. All right, there we go. So we've got the pass-through now. From the inside, you can see I went just in front of that receiver there. Now I'm going to do the same thing on the other side. All right, now that we have our pass-throughs for the LED lights, we're going to move on to these ladder rungs. And a lot of people really struggle with this, and a lot of it has to do with the fact that you need to have the right tools in order to do a good job of it. What I like to use is this little electric drill. You've seen me use it before, and that's chucked up with a drill bit that's the same diameter as the brass rod that was supplied with the kit. And all of the ladder rungs are marked out with little dimples on the sides and top of the wheelhouse. And all we're going to do is put the drill bit in the dimple. We're going to drill each one of these out. There we go. So you've got the 5 ladder rungs on the side and the 1 on the top. Because the dimples are all marked out, everything is evenly spaced and ready to go. So the other thing that I like to use here, and again, not a necessity, but certainly makes your life easier, is this little deal from Micromark. And this is designed for creating ladder rungs. They call it a 8475 grab iron bending gauge. I use it obviously a lot because I do a lot of builds, but the way that this works is you measure out the width that you are going for. In this particular case is 0.2 inches. Pin your brass rod, tighten down the clamp, and then you use some needle-nosed pliers to bend, pinch, loosen, and what you've got now is a perfectly spaced ladder rung. And each one of your ladder rungs will be completely uniform and perfect. So you just snip this off at the appropriate depth or length, press fit them into place, and secure it with a little bit of thin CA glue. Alright, I'm just going to show you the press fitting of these. This is my ladder rung trimmed to size. I'm going to set the base in there, just give it a little bit of a wiggle, and there we go. Perfect little ladder rung. Now we just need to do that 11 more times. Okay, we're going to get ready to attach the wheelhouse to the upper hull here in a few moments, but before we do that we need to do a couple of things. I'm going to drill out the receiver here for the depth tube. So that passes all the way through the hull so that we can get an LED light shining up through the bottom. The other thing that we are going to do at this point is glue our ship's wheel onto the hull there using some rubber CA. Beautiful. Alright, what we are going to do next is we're going to install some LED lights into those alligator eyes. Now, these are going to come with your LED lighting kit. They're all pre-wired for anything from 6 to 12 volts. They come set with stripped wire, about 12 or 14 inches of lead. What we're going to do in preparation here is we're actually going to just sand the tip of the LEDs off flat. So I'm going to use my sanding drum on my Dremel. You can use a file, but just flatten it and make sure you don't go too deeply. What that is going to do is it's going to disperse the light, so it's not a spotlight, it's more of a floodlight. It makes quite a big difference when viewing the model from many different angles. So let's grab one of these LEDs, and what we're going to do is bend the tip at about like an 80-degree angle. So what that's going to do is it's going to make it easier when we thread this in to get the LED pointed out. And this is going to take a little bit of wiggling and such, but there you can see came through without too much of a problem. Once you get that somewhat in place, what you're going to need to do is bend it into position using like a small screwdriver or something like that. Okay, so our LEDs are now in place, centered in the openings there, making sure that they sit back or flush with the leading edge of the alligator eye so that we can put our lenses on a little bit later on. So now what we need to do is address these crazy wires coming out, and what I like to do is pull them aside and kind of pin them to the side of the wheelhouse, and the objective is to have them exit right at the crease of this wheelhouse. And what I'm going to do is just use a little bit of thin CA glue, and that will adhere the wires to the side of the wheelhouse and keep them in place for installation. Okay, my wires are now adhered to the insides of the wheelhouse walls. At this point you can use some paint, and you can paint over the wires if you want to conceal them. I actually like just that little punch of color. It draws your eye to the inside of the wheelhouse. I really don't think it's a bad thing to leave them exposed, but you can cover them up, paint it out if you would like to do so. What we're going to need to do now is drill out the receiving holes in the upper hull, and that's going to be obviously at the same point, the creases of the wheelhouse. So we're going to want to put just a small hole big enough to allow these two wires to come through right here. So right at that crease here and here, we're going to drill two holes all the way down into the hull. All right, we've got the pass-through holes complete. Now we're going to thread our LED light leads through each of those holes. And there we go. It's just kind of a test fit here right now. So there's the inside wires coming out through the inside of the hull there. So at this point, you'll notice I did not put the depth tube inside, because we still need to do a little bit of adjustment with the wheelhouse here. Now, this is very typical on this particular model that the wheelhouse has a gap in the front. Two ways to address that. You can glue everything down and then fill that gap, but what I actually like to do is try and get that fitting a little bit better through the gentle use of a heat gun. So that's what we're going to move on to here right now. Now when you use a heat gun on these parts, you're going to want to make sure that you do not overheat the parts. You're going to get sagging, massive distortion, and you're going to ruin your parts. You're going to use a low setting on your heat gun, and you're going to concentrate just on the walls and forward section of the wheelhouse. So just heat it gently, and this will take a few minutes. And if you watch closely, what you'll see, as soon as the piece starts distorting, you'll know that you are almost at the right temperature of the resin to get it to sit for you when you press it into place. So taking a look at that now, you can see I just pushed it down and everything just kind of settled, back where it needed to be. That is a nice flush seam on the front of the wheelhouse there, which is exactly what we are after. I'm gonna hold it in place here for a couple of minutes until that resin cools down, and once it does, it'll retain the shape that we just forced it into. Okay, in preparation for the next step, we're going to break out the clear pieces. We've got the salon windows and the wheelhouse windows. We're after the wheelhouse windows. I find to cut these out, scissors do the best job. Now what you're going to want to do ultimately to cut these parts, and I'll zoom in here for you, is cut it approximately 1/16 of an inch back from that seam. So what I do is I start from the outside, I cut around and around and around and around until I finally get just where I want to be, about 1/16 of an inch from that edge. So we're going to take our scissors, and like I said, just going to start working around, clearing out this excess plastic so it becomes easier and easier to work on. Take your time. If there's any pieces that people will screw up on a regular basis, it's the clear parts. And there we go. As easy as that. Now we're going to do the same for the other side, and we'll be ready for installation. All right, just before we install the windows on the wheelhouse, what I'm going to do is prep the wheelhouse for like the RC aspect of this, and that's the venting of all the trapped air that's going to be in that wheelhouse. And what I'm going to do to solve that issue is drill a pair of holes right next to the alligator eyes that are going to be on either side of that raker arch support. And where that's going to be is right at this crease, and I'll get one finished here. So you can see that location goes right through. It's really going to be hidden for the most part between those alligator eyes and behind that raker arch support. Vital to make sure you don't have trapped air in that wheelhouse. You do not want that by any stretch of the imagination. So I drilled one, now I'm going to drill the other one, and we'll move on to the next step. All right, our vent holes are now in place. Now we are going to fit our windows, and these are actually really easy to install. You just press them in from the back using your finger, and you push them forward until that crease is even with the outside of the that ring around the outside, and that's a friction fit there right now. I'll do the same on the other side. Perfect. So now that that is done, what we're going to do is use just a little bit of thin CA glue and just put a little tiny drop on the inside edge and let the capillary action draw it around the remainder of the window. All right, boys and girls, now is the time you need to gird yourself up to become very frustrated, because this is likely going to take you a couple of tries. And we're talking about this rear window on the wheelhouse. So what's supplied with your kit is this sheet of clear plastic, and what we need to do is cut it to shape and then install it without getting fingerprints or glue all over it. So what I like to do is put the window in place, and with the sharp knife mark out the edges. Very carefully. So that done, I am going to now scribe and cut that, and we'll move on to fine-tuning the fit here. All right, here you can see the results of my first cut. Now I only made 2 cuts, one across the top and one across the side. This side is angled, this one is still straight from the stock material that I had, so I'm going to need to angle this a little bit, and it also looks like I need to take just a 32nd of an inch off the top. So what you're going to want to do is just make a cut, clean it up, test fit it, try it again, and keep going until you get a perfect fit. Now this plastic is thick enough that you can actually use a file to fine-tune the contour. All right, here you can see the results of my efforts to get that window to fit. Now what I'm going to do is just take my thin CA glue and just in the corner, just touch the window and let it flow around the perimeter. Just like that. So it is now sealed up, in place. We've got all our windows in place. We got our vent holes. We're ready to install this thing. All right, in preparation for mounting the wheelhouse onto the upper hull, we need to do one more thing, and that is install some green LED lighting for the interior of the wheelhouse. And in order to do that, I'm just going to drill one hole, and this is about an 1/8" drill bit, and that's going to be right in the center. And what we're going to do is we're going to mount 2 of these 3mm LEDs in that front area there. So here's the 2 of the pre-wired LEDs. We're going to do the same thing to the tips of those that we did with the other ones, and that's going to grind them flush. Now what we're going to do is we're going to feed these wires through that hole, and that'll leave the LEDs shining forward, and we'll angle them in a moment. Alright, I threaded in my LED lights. Now what we're going to do is we're just going to angle them so that they shine kind of into the wheelhouse, up at an angle. And you're going to want to kind of push them flush with the floor, just like that. And then a single drop of CA glue will hold them in place. Alright, now what we are going to want to do is grab our depth tube. This is that clear acrylic tubing that came with your kit, and we're going to press that into the receiver in the top of the wheelhouse there, just like that. And now, kind of the tricky part, we're going to need to thread our wires back down into the hull. And then as we drop this in place, we're going to need to line up our depth tube. So that gets into the proper hole. And then just press everything down. There we go. Just like that. So now, before we seal everything up, is a great time to check all of the LED lights and make sure that they're functional. So to do that, I just got a little battery pack here. This is a receiver battery pack, 5 volts. But you can use a 9-volt battery and just touch things to the terminal. So I'm just going to push these leads into the battery here. There we go. We got some green LEDs in the wheelhouse, and they're a little dimmer than they're going to be. Obviously, these are running at about half of the voltage that they will be. And we'll check our wheelhouse alligator eyes here. There we go. So our LED lighting is functional. I'm going to do a last check. I'm going to take a polishing cloth, wipe out the inside of those wheelhouse ports, make sure they're nice and clean before we button things up. And then we are going to secure it in place. Alright, I have the wheelhouse secured to the upper hull. I've used some thick CA because there was just a tiny bit of a gap in there, and a toothpick filled all of that in. And you want to check for light leakage by running your leads to power, making sure that there's no leakage from under that seam there. So what we're going to do now is just going to move on to the securing of this raker arch. And I find typically what you need to do actually is remove a little bit right from the forward edge of this raker arch so that everything sits nice and flush. You can see as it sits right now, there's about an 1/8 of an inch gap up on the top so it doesn't sit flush. So I'm just going to use a file. We're going to file that down so it sits nice and tight. Alright, we got the part prepped. I'm just going to use a little bit of the thick CA on these leading edges here. Just like that. Hit it with a bit of accelerator and that will lock that piece in place as well. So from here, we're going to move on to installing the front hatch, and we're going to do that just like we did the dorsal hatch. I'm going to get it set in place, get our drill bit, drill through, mount the pin, cut it flush, and we'll be ready to go there with a functional forward hatch. Alright, we are coming right along. What we're going to do here now, we're going to drill a few more vent holes in this upper hull. Now, because of the contour, the inside of this hull, air is going to want to naturally gravitate out through this forward hatch, up into the wheelhouse, out those vents we drilled earlier, out the back of the staircase here. It's not really till we get to the middle of the boat and the back side that we need to worry about venting. So what I'm going to do is I'm going to put a pair of holes right behind the rear breather to either side of the forward part of that raker arch. And then the last two are actually going to go right at these vents just in front of the skiff. You can see these two round detail areas. Right here. Conveniently, this works great to put a pair of vents as well. There we go. Our upper hull is now vented. Now is actually going to be a really great time to make sure that we protect our clear pieces. We're going to mask off our main viewports and the rear viewports with some masking tape. Alright, the next thing that we need to address is drainage for the boat. You can see if we were to fill this with water, as it will be during operation, it will act like a gigantic cup. Water won't come in and it will not get out. So what we need to do is drill some drainage holes. Unfortunately, it's on the bottom face where you're not going to see it, even in static display mode, unless you get underneath it to take a look. So what we're going to do is we're going to put a series of holes along the keel, specifically and for the most part at this center section, the lowest part of the boat, so that when you bring this out of the water, everything drains nicely. And all we're going to use for that is a 1/4 inch drill bit. You can place these where you want to, but just try and do so in locations where it will be hidden by other cosmetic features of the bottom. So we'll go ahead and place those, and I'll show you where I put my holes in a moment. Okay, here is the drain hole pattern that I put in the bottom there. I got slightly larger holes in the center, slightly smaller ones in the side to miss the side keel. This will be adequate to allow the bottle to drain. If there was a lot of freeboard on this model, you might want more because you're going to be moving more water in and out as it surfaces, but as it stands, this Nautilus has only about 10% of the hull above the water line, so this array of drain holes will be completely adequate to drain it. Okay, what I am going to do next here is pre-drill the holes for our LED lighting. You can see I've done so on this port side. That's a 1/8 inch bit right in the center of each one of those holes. Now I just want to make a note here. On the inside, we were left with this lip, this thin lip on the inside. When you pre-drill these holes through the hull, you'll see that you're going to penetrate in here. So that'll mean that when you drop your hull on, your upper hull on, your LED lights would interfere at these points. And so all I did is I just used the sanding disc and ground out this area here to make sure that there was no interference on the inside. So I got port side done. I'm going to work on the starboard side. Just want to show you what I meant. So I drilled the holes through the upper hull into the lower hull, and you can see that they would interfere all through here when we drop things down. So again, just going to use this sanding disc, and we're going to grind all that out to make sure that we don't have any issues. Alright everyone, I think that is enough for this chapter, because we're starting to get into the time that we're going to be thinking about the cosmetic aspects of this boat, primer, paint, and weathering. So I hope you enjoyed this chapter 2 conversion of this 77 scale Nautilus Drydocks Disney Nautilus model to RC control. Hope you'll join me for chapter 3. If you like, please subscribe. Visit my website, www.nautilusdrydocks.com, for this and many other fascinating subjects in the hobby of RC submarines. Thanks for joining me, guys. We'll catch you next time.